Okay, class 2 alpha. Good morning. Can you hear me? Can you hear me? Are you still there?
Can.
Yes, can.
Okay, thank you for your response. All right, thank you. Okay, my presentation, I will share my screen first. Okay, screen sharing check. Can you see my screen sharing?
Can.
Can Okay, okay. Very good lah, boleh lah. Okay. Okay, good morning to Alpha. Okay, how do you do today? I hope everybody is in a healthy condition. Semua sihat macam biasa. Okay. So before we start our lesson for today, do you have any question about the workbook exercise that I gave you yesterday and on Monday until page 109? Okay, page 109. You can check your workbook. Do you have any question or any confusion about the question on your workbook chapter 8 until page 109? Until page 109. Any question? Okay. 106 is very easy, very straightforward. All right. Page 107 also, yeah, very what we call a straightforward answer. You just need to what we call identify the parts of level, and then you just and also you try to identify the classes of level, whether it is first class, second class, or third class, right? And then also in page 107, the calculation using the principle, using the formula to solve the principle of level. Okay. I will try to share the question first. Okay. So for page 107, question number 3, this is page 107, question number 3. The answer is 750 Newton. Okay. But usually, in the question paper, in the examination or in the question paper, the formula will be given. All right. The formula will be given. So you just need to replace, or you just need to substitute the value given to the formula, and then you try to solve the question. All right. So question number 3A, page 107, is 750 Newton. And then for the question B, answer for the question 3B is 200 Newton. All right. So what do you want to find here? You need to identify the effort, the distance from the effort through fulcrum, and also the distance from the load to fulcrum. Okay. But for question this one, for this type of question, right? You can refer page 107, page 107. The information is all there, right? The information is all in here. Okay. It already gives you the distance from the, for example, the 3 meter over here. This is the distance from where? Distance from where? From effort to fulcrum. 3 meter. And then this one is the distance Distant or distance? Distance. Distance. Distance is, okay, sorry. Distance ialah jarak. Distance. Right, distance, right. So this one distance from what? Class. 1 meter over here. Huh? So you identify first lah, right? Identify the parts first. So this is effort, this is the fulcrum, and then this is the load. All right. So the 1 meter here is the distance from the load to fulcrum. Okay. And then equal times the load, and then this is times the effort. So this is already give you the what? So already give you the effort. Effort is 250 Newton, and then you find the load. You just multiply it. All right. So the answer will be 750 Newton. Okay. Is it okay? This question, page 107.
Yes.
Okay. Okay. So this is what class of lever? This one. Okay. What class of lever? First, second. Okay, very good. So this is the first class of lever. Why first class of lever? What is your reason you call it first class of lever? Because why you said this is first class lever? Because what?
Fulcrum at the middle.
Yes. Oh, you're very big. Sorry. What happened? What happened? Oh, this one. Okay, because the fulcrum, because the fulcrum over here in the middle. Or you can say that the fulcrum is between what? Or you can say the fulcrum is between what?
Effort and load.
Yes. The fulcrum is between fulcrum. The fulcrum is between effort and load. So that we call it first class lever. Okay, this is for the question number 3B, page 107. Okay, how about the next question, question 3B? Okay, again, same formula, but different class of lever over here, right? Okay. This one over here. This is distance from where to where? Distance from, okay, identify the parts of lever first. So this is fulcrum. This is load. And then this is effort. Okay. So 1 meter is from fulcrum to effort. Right. This is distance from fulcrum to effort. How many? 1 meter. How about this one? This is the distance from
Load to effort.
Yes, from load to effort. 0.5 meter or 50 centimeter. Okay. And then you just equalize it times what? Times effort. And then this one times the, effort. F to E, yes. And then this is times load. Distance from, not this one, sorry. F and L, load is 500 meter. Okay, not this one, sorry. Not this one. Okay, distance from fulcrum to effort, and then distance from where actually? You must take this distance. Okay, distance from fulcrum to load. Actually, you want to take this distance, not this distance. All right, what we call from fulcrum to load. Okay, fulcrum to this one, you take this one. Y over here lah. Distance from fulcrum to load times the load. Okay. So what is the distance from fulcrum to load? What is the distance? Fulcrum to load? You just minus 1 meter minus 50 centimeter. So you also got here 50 centimeter. Is it correct? And then you calculate, you substitute the, what we call the value, and then you get the answer. Is it okay, class? To alpha? Boleh,
Okay.
Okay, so the answer here
Boleh.
is, okay, good. 200 Newton. Right? Okay, never mind. So we go to the next question, page 108. So this is the moment of force. Yesterday we already learned about the moment of force, and then make sure you can differentiate which one has the greater magnitude of moment of force and which one has the less magnitude of force. Okay, if you look at these two pictures over here, page 108, okay, 208. Okay, which one has the greater moment of force? Greater moment of force, is it A, situation P, is it situation P or situation Q? Which has the greater moment of force, you think?
Situation P.
Situation P or situation Q? The longer distance from pivot to effort, the longer distance, the shortest distance or the longest distance? Which one? Q or P has the largest moment of force?
Q.
Q, you must remember. Situation Q, okay, has the, what we call greater or more moment of force, because the distance from where? Because the distance from the perpendicular distance. You still remember the perpendicular distance from the fulcrum or from the pivot to the effort is longer. Okay, 0.3 meter. 0.3 meter is, of course, is longer than 0.2 meter. All right. So, which situation that the person need less energy or less effort to turn the boat? Only less. It doesn't need much effort. It doesn't need much what we call force to open the screw there. Which situation, P or Q? P or Q, you think? Okay, correct. Yeah, the answer is Q. Okay, the longer the distance, meaning that the less effort you need to open the screw. Okay, the shorter the distance between the pivot and the effort, the more what we call force or the more effort you need to open the screw. So Q is better. Q is you choose Q, all right, in order to take less effort or take less energy from you to open the screw over there. Okay, is in situation Q. The longer the spanner, the less the effort you need to open the screw. Okay, you understand this, right? Okay, next one. Opening the door also, opening the door. All right, you can see what we call the distance, the perpendicular distance from the effort or from the force to the fulcrum here. Okay, one is 0.8, one is 0.2. Okay, one 0.8, one 0.2. Okay, right. So which are the answer? Okay, for B, smaller force is exerted in the situation P compared to situation S. A larger force is exerted in situation P compared to situation S. These are the answer for a question on page 108. Okay. Next one. Any question here? I just jump to the calculation only lah, yeah. Right. Very simple one. You just multiply the distance and the force here. So you get the moment of force. Okay. I think this is very straightforward and very easy. Right. So you just divide here. Not divide. You just multiply. Now multiply the distance perpendicular distance from the pivot to the force and then the force itself. So you get here the answer is 3 Newton meter. Okay, 3 Newton meter of force. All right. You can see here between question A and B, the moment of force is same, 3 Newton meter. This one also 3 Newton meter. Okay. So if you use shorter distance, you need more energy here. You see, 15 Newton. You need more energy to what we call to pull the spanner, 15 Newton. But if you what we call the perpendicular distance is more, for example, in question B, 0.3 meter, so you need less effort, only 10 Newton in order to open the bolt here. Can you understand this? Can, huh?
Yes.
Very easy, right? Okay. Next one, this is the door. Also, you just multiply lah, yeah. Multiply the distance and the what we call the force needed. Okay. Of course, if the distance is here, for example, if the distance is very short, in D here, only 0.2, only 0.2, okay? Only 0.2 meter the distance. So you need more energy. You need more what we call momentum, not momentum. You need more force in order to open the door because the distance is very short. So if you have over here 0.8, very longer perpendicular distance from the effort to the fulcrum, so you only need less effort to open it. Only you just need about 10 Newton in order to open it. All right, a very easy one. Okay, so moment of the force depend on the force applied and the perpendicular distance from the pivot or the fulcrum to the force, right? Okay, I hope you can understand this. Later on, you can see my video again on later on when I give you the video later. Okay, today. All right, still in 8.2, we are going to learn about pressure. Later on, you can open your textbook also, page 187. So, what is the pressure? All right. Okay, you have learned force is a pull and a push applied on an object. Okay, if you still remember 8.1, what is the force? Is the push or a pull applied on an object. Okay, but sometimes, sometimes the problem here, sometimes large force cannot push or pull a small object. Why? Okay, it is not what we call definitely. If you have a larger force, sometime when you want to move or you want to what we call move the smaller object, it cannot move. So why? Because of the pressure. Okay, for example here. Okay. With the same, can you see the picture over here? A and B? Can. Okay. You just imagine the force it need for our finger thumb to apply the force is same amount. Same amount, yeah? You just remember this. The same amount of force needed in order to push the object by our thumb. Sama saja dia punya the force here. So which one is you think has the highest force? A or B? Teka saja tak apa. The highest pressure, between A and B. Which picture has you must apply highest pressure?
B.
Yes, B, right? Okay, why? Because it has to do with the surface area over here. If I can draw the picture over here, okay, I try to draw it. This is thumbtack. Okay, this is thumbtack here. These are the surface area over here. And then this is a coin. So this is the surface area of coin. Which has the larger surface area? Which? Coin, X or Y?
Coin.
Coin has the largest surface area, right? So if the object has the largest surface area, what happened to the pressure?
Under a larger pressure.
Larger pressure, right? So you need a larger pressure because the coin over here, XX, has the largest surface area. But why we have tiniest, very small surface area over here? So you just need a less force to what we call to push the object over here. All right. So we go to the next question, next topic. Okay. The example show the effects of force acting on the surface depend on the surface area where the force is applied. Okay. Force applied on a smaller surface will result in larger pressure. Okay. Sorry. Again, you follow the textbook. Force applied on the smaller surface will result in larger pressure. Conversely, the same force applied to the larger surface will result in smaller pressure. Okay. Sorry. Opposite. Okay. Smaller surface area, you have larger pressure. Biggest surface area, you have lower pressure. Okay, and then you can use the formula over here. The formula to measure the pressure is force divided by over surface area. Okay, these are the what we call the formula for pressure. Force over surface area. Force in Newton, and then surface area in meter square. Square meter. Square meter or meter square?
Meter
Class?
square.
Meter square. Meter square. All right. Okay. Okay. For example, the picture over here, why doesn't an elephant weighing 5,000 kilograms sink into the ground? Because the surface area of the elephant soul is large. Therefore, only small amount of pressure is exerted on the ground. Because of the surface, what we call surface area of the sole of the foot of the elephant is large. So the elephant will not sink into the ground. Yeah. Okay, never mind. Okay. So actually there is an experiment. You very hard to do lah without the experiment. Yeah. Okay, never mind. Where is the question? Okay, pressure. Pressure. Okay, this one. Right. Okay, never mind. There is another page. Experiment. Where is the experiment? Experiment. This one we already do. Electricity. Tak sempat. Okay. Alright. Wait, huh? Okay. Pressure. For example here, yeah. For example, pressure, pressure. So what is the formula for pressure? The formula for pressure is force in Newton plus divided by surface area in meter square. Okay. So for example, we take what we call same amount of object. Okay. We just take same amount of object. For example, I have here a small same shape, same amount of object right here. How to enlarge this? Okay. What happened here? Okay, and then duplicate. Very slow lah, this one. How to rotate this? Okay. Okay, class. Sorry, a bit late. Right. For example, I have two identical object here that weighing 100 Newton and 100 kilogram. For example, yeah, this is 100 kilogram. What happened here? 100 kilogram. This is also 100 kilogram. Okay. What we call this is what we call same amount of force. Okay, same amount of force, yeah. Okay. The next one. Never mind, I just draw it like this lah, yeah. Same amount of object, same amount of force. Similar object lah, yeah. Similar object. Similar object. But the position only different. The position only different. Okay. So what I mean by similar object, this is, I just take the distance here is about 10 centimeter. And then the object here, the distance, the size from the width and the length is, this one is about 20 centimeter. Okay, this is also same lah, class. This is also same. And then the height, the height over here is also 10 centimeter. Okay, can right? So this is also the same. Okay, for object B, this is object A, and then this is object B. For object B, what is the height of it? This is how many? I said identical, right? So this is also 20 centimeter. Yes. So this is how many? The width?
10.
10 centimeter. And then this is also how many? What is the length here? Also?
So
10 centimeter, right? Okay. But the weight is same, right? You can see here the weight is same. Dia punya berat dia sama. The force exerted, what type of force? Gravitational force, or the weight is the same. Okay, so how can you prove that the pressure in B is more than pressure in A? How can you prove it? You use the what? You use the, what is this?
Formula.
Yes, you use the formula. Can you try to calculate it for me? What is the pressure in A? Pressure in A, pressure in A, pressure equal to what are the force? How many force? Force in Newton, Okay. Force in Newton. So you need to convert kilogram to Newton. How many? Anybody?
10.
Okay, 1 time. Okay, very good. 1,000 Newton. Okay, remember 1 kilogram equal to 10 Newton. 1 kilogram equal to 10 Newton. So you have 1,000 Newton. And then what are the unit of pressure? The unit of pressure is not Newton meter square. Newton meter square, right? And then what are the surface area? Surface area for A, how much?
200.
200? 20? How do you want to find the surface area? Surface area is 10 centimeter times 20 centimeter. Is it true? Right, surface area, right? For A. Right. So how much? Or you must, you must what we call convert it to meter first. Convert it to meter first. So we have here how much? This is this one lah, 10 centimeter, 0.1 meter times 0.2 meter. So it will become how much? Berapa? This is for A, This is for A. And then for B, same amount, pressure equal to same amount of force in Newton, but the surface area is different. All right, the surface area is 0.1 meter times 0.1 meter. So, what the answer for A? Ah, 0.1 times 0.2. Oh, saya matematik kira-kira sangat lemah. And then 0.02 this one is 0.01 lah. Okay, never mind. Later on, we change the what we call the unit lah. All right. This is 10 times 20. And then this is 10 times 10. So this is 1,000 equal divided by 200. Right. So this 1,100. So what's the answer? 5. This one. Okay. This one answer. B. Where's the answer for B? In class, can you understand this? Can ah? Boleh faham tak? 1000 divided by 200. 1 is 5. And then 1000, 100. 10. So this is 10. This is 5. This is 5. And then this is 10. Okay. Then you convert lah. Barulah you convert convert kepada meter. Okay. So this is actually n centimeter square. Nah, 10 Newton centimeter square. Okay. Or 0.5 Newton meter square. Okay. And then this is 0.10 Newton meter square. So which one has the highest pressure? B or A? Which one has the highest pressure? This is for A and then this is for B. Which has the highest pressure? A or B? B lah B has the highest pressure. Okay. Why? Because B has 10 Newton. 10 Newton per centimeter square. Okay. And then A only have 0.5 Newton meter square. Can you understand this? Boleh tak? So meaning that the smaller surface area, alright, smaller surface area, the surface area on this side, for example, I use the blue one. This is the surface area for B. This is surface area for B. 10 times 10 only. And then this is the surface area for A. This is surface area for A. 10 times 20. All right. So there's what we call the smaller surface area, the larger pressure it exerts. The big surface area, larger surface area, it has the what we call the lowest or the lowest pressure. Kan? Boleh? Boleh faham ini?
Boleh.
Apa yang sama? What are the constant? What are the constant value here? The constant value is A 100 kilogram. Yes. And then B also we use the same object but we position it a bit right, different. A 100 kilogram, B also 100 kilogram. So same force. Okay. How we want to, my question next is how that we want to equalize the pressure. How we want to equalize the pressure? What is your idea?
Change the position.
Yes, again.
Change the position.
Change the position, very good. If the position same position, how do you want to add the pressure on A? If the position is same position, but you want to equalize or you want to add the pressure at A over here, you must add what? What is the idea? You want to make the pressure on A also 10 Newton centimeter. You must what can you increase? You must increase it to what, class? Any idea? You must increase it to how many? 200 kilogram lah. Right. You increase the what we call, you must increase the force, then it will be, the pressure will be equalized. Can you understand this? Or you take another one, or you take another similar block, you put at the top. You take the similar block, you put at the top, then the pressure in B will be equalized. For example, you take another same block over here. You put at the top. Okay, this is 100 kilo. This is also 100 kilo. So now the pressure is what? What happened to the pressure? Equal or different between A and B?
Equal.
Yes, it will be equal. That's all. Okay? Alright. Okay, boleh faham ini ya? Say you take another block, so the pressure will be equal. It depend on what? Number one, please remember, it will depend on the force and then the surface area of the object we want to measure, the pressure here. Any question?
No.
No.
Oh, I take extra time. I'm very sorry. Sorry. Okay, never mind. Ayo. Do you have class right now? Okay, sorry. We see all again on next week. I will give the extra the question for you to do after the class. Okay, class. Sorry for the extra time I take. You can leave the class right now. Thank you for your focus and attention. See you all next week. Bye-bye.
Thank you, teacher.
Thank you.
Thank you. Bye. Thank you very much. Ayo.